Welcome back. In the former video, where we started sequence and series, we were introduced to arithmetic progression. And in this video, we are going to be discussing geometric progression. Alright, take for example, I have a sequence like this. 2, 4, 8, 16, 32, and so on. Now, we are going to see that they differ by a consistent term, but the difference, what is common between them is not a difference. Now, it is not a difference; it is a ratio. How do I mean? Now, because in an arithmetic progression, the relationship between the terms was addition and subtraction. In this case, the relationship between the terms is multiplication and division. Hence, if you want to understand what is common between all of these terms, what we simply do is that we take the ratios of each of two consecutive terms. Now, let's go in the way we did the other one. Now, how did we get 4? Now, we came about 2, which is still the first term, and in this case, our first term is still going to be 2. But how did we get 4? We started with 2, we multiplied by 2, and it gave us 4. Now, how did we get the next one? We multiply this guy by 2 again to give 8. How did we get 16? Multiply this by 2, we get 16. How about 32? Multiply this by 2, we get 32. So what does this mean? It means that every term is multiplied by 2 in order to get the subsequent term. Alright, so what does this mean? It means that this multiple of 2 is common between them. Now, to get what that common term is, it definitely means that if it's a multiple of 2, it means that between this and this, a ratio of 2 exists. Between this and this, a ratio of 2 exists. Between this and this, a ratio of 2 exists. Alright, definitely we will call what is common in between them a common ratio, rather than a difference right now. A common ratio. Remember, in the term that I explained to you that I brought up during the AP, we were doing successive addition so that we could get that a common difference existed. Now we did a successive multiplication so that we get that a common ratio exists. Now, our common ratio can be gotten by taking T2 divided by T1, or T3 divided by T2, or T4 divided by T3. Any two consecutive terms, as far as those terms are following each other, then you can take their common. You can use it to derive your common ratio. All right. Common ratio is given by R, and first term, as we already know, is given by A. In this case, our common ratio is going to be 8, for example, which is the third term, over 4. That is what? 2. So our common ratio is 2. Our first term is 2. Alright. Now, let us derive an equation for how to get the nth term of a GP. Now, it's very simple. Watch closely, just like we did in AP. Now, what is my first term name? My first term is A. So T1 is equal to A. Now, my second term, how did I get my second term? We said this will be T1, T2, T3, T4, and T5 respectively. Now, how do I get my T2? I am going to remember from what we did last, we have gotten our common ratio to be 2, isn't it? Alright, so how do we get the next term? We simply multiply this, our first term, 2, by the common ratio 2. So what do we have? We have T2 will be equal to A times the common ratio. The first term times the common ratio. How do we get T3? T3 will simply be A times, T3 will simply be A, it will be this second term, T2, times the common ratio. T4 will be this T3 times the common ratio. And T5 as well will be what? T4 times the common ratio. Alright, let's express this further. You know that T2 was A times R, which was A times the common ratio. That would be A times the common ratio, then times the common ratio again, which is 2. So we change this to r, which is common ratio, times r, and this becomes a times r, that is r squared. R times r is r squared. So we have this as our T3. Now what does this give us? We have T3, which is now AR squared times, now what is our common ratio here? 2, of course, in this case, but it is given by R. Let's say we'll just give an nth term. So it's going to be what? R equal to AR raised to power 2 plus 1, that will be what? 3 now. Then in the next term, we have, this also becomes common ratio because, of course, 2 is a common ratio. So we have T4, which was, T4 here was A raised to power 3 times R. So that becomes A raised to power 4. Now, if you are following from what we did in AP, you will see a consistency here. When we have T1, we have only A. When we have T2, we have R raised to power 1. When we have T3, we have AR raised to power 2. What does that mean? It means that if I have T5, I will have R raised to the power of this one minus 1. 5 minus 1, which is what? 4. AR raised to power 4. Isn't it? So it means that our nth term therefore becomes AR raised to power the particular n minus 1. And that is how to find the nth term of a GP. This is the formula for the nth term of a GP. Alright, so for example, let's use this question. If we're asked to find the, let's say, so we have the nth term to be equal to AR raised to power n minus 1. If we ask to find, for example, the 16th term of this sequence here, so find T16. So T16 is equal to AR raised to power 15. Look at the way I did it. Just the way we did the other one. If it was AP, T16 would be what? A plus 15D. The same way here, because it is GP, to be AR raised to power 15. Alright, so now what is our first term A? That is 2 times, what is our common ratio? 2 raised to power of 15. And then you solve 2 times, that will basically be 2 raised to power 15, that will be 2 raised to power 10 is 1024 times 2. Alright, you are going to use your calculator and you get your answer here. Okay, let me quickly resolve that. Now, 2 raised to the power 15 is going to give us 2,768. So 2,768 times 2 is going to give us 65,536. And that becomes our answer in this case. So what does that mean? If you have to find the 5th term, you simply say AR raised to the power 4. You have to find the 99th term of a GP. It's going to be what? AR raised to the power 98. Do you understand? Alright, so that is how you go about AP. Now, let's solve some questions under GP. Let's solve some questions under GP. In the next video, we are going to now consider what is called the arithmetic mean and geometric mean. Inserting arithmetic mean between terms and inserting geometric mean between terms. But quickly, let's solve about 2 questions on this GP. Now let's consider these 2 questions. The first one says that what is the nth term of the progression 16, minus 8 and 4. So we have the progression 16, minus 8 and 4. Then we have to find the 17th term. So what do we do here first? We are going to find the nth term. Alright? By finding the nth term, it means that since we already have the 3rd term, which is the last term here, of course that formula also stands for last term. So we have the last term is equal to AR raised to power n minus 1. So the last term here is the 3rd term. So we have T3 is equal to what? A raised to power 2. T3, A raised to power 2. AR raised to power 2. So T3 is 4. So 4 will be equal to, what is our A? A is 16. Then R, what is common ratio now? So we have that A equals 16. R will be equal to any 2 consecutive terms. We take their ratio. Now the minus 8 and 16 is equal to, we are going to get the same thing if we took 4 over minus 8. Here 1, here 2, minus 2. Here 1, here 2, minus 2. minus 1 over 2 rather. So we have times minus 1 over 2 all squared. Now that is the third term. Alright, okay, since we are asked to find the nth term, okay, the nth term, this one will be after finding our a and r. So r is given by as minus 1 over 2 here. So nth term is equal to ar raised by n minus 1. So n is unknown, so we have t n is equal to, what is a? 16 times, what is our common ratio? Minus half raised to power n minus 1. And this becomes ta is equal to 16 by, this becomes minus half raised to power n divided by half divided by minus half. Alright, divided by minus half. Because it is divided by minus half because this is raised to power minus 1. This is raised to power minus 1. So what do we have here? We are going to have that Tn will be equal to, now this is going to, okay, let's express this in full. It's going to be 16 times minus 1 over 2 raised to power n, then divided by minus 1 over 2n. So division changes to times so that we have Tn is equal to 16 times, I can bring, okay, it's going to become, if I bring it forward, it's the same. So it becomes, but let me just leave it this way, minus 1 over 2 raised by n times 2 over 1, minus 2 over 1. So this can multiply this so that we have Tn becomes 32, minus 32 over 1, that is minus 32, into brackets, times minus 1 over 2 raised to power n. Alright? So, and this becomes our expression. So that will be, we can collect them together, n equals to minus 32 into bracket negative 1 over 2n. And that is our answer. Now let's go on to the second question. Now the second question says that we should find the 17th term. So T17, the B part says T17. Now we already know that this is our nth term, right? So we can basically plug in that value and it becomes minus 32 open bracket minus 1 over 2n. Now if you were to use the formula directly, I will use the formula directly and show you that we'll get the same answer. So we're going to have minus 32. Now n is now 17, of course. So you have minus 32 times minus 1 over 2 raised to power 17. Now this is it. Because this power is an odd number, so we are going to be left, our minus will be retained. So since minus will be retained, how that is clear. For example, I have 2 times 2. If a minus was in front, if it was minus 2 times minus 2. Now, because it is square, the power here is minus 2 raised to power 2. So if it was, because it's an even power, minus will cancel out. Now if it's an odd power, let's say 11, our answer is going to be a minus. If it was 16, our answer is not going to be a minus. Alright, keep that in mind. Because it is even. So the minus will cancel out. So here it is odd. So what do we have? Our minus is going to retain. So we have minus 32 times minus 1 over 2. 1 raised to power 17 is 1 raised to power 17. And over this 2 raised to power 17. So from what I have here, I know that this is also in the can be expressed in the base of 2. So I have minus 2 raised to power 5 times minus 2 raised to power minus 17. Is that? So what does this correspond to? Minus 2 raised to power 5 times minus 2 raised to power minus 17. Alright? These all together like this, and these all together like this. So we will indices, we'll solve by indices. So we have 5 raised to power 5 plus minus 17. So that becomes minus 2 into bracket 5 minus this becomes minus 12. Alright, so what does this Now, minus times minus is going to give us plus. So this is going to be out. Minus and minus is going to give us plus. So we have just 2 raised to the minus 12. And our answer is going to be 1 over 2 raised to the power 12. Alright, if you want to solve for that, that becomes 1 over 1024 is 2 raised to the power 10. So 2048 and 4096. So the answer is going to be 4096. That is the answer for the T17. So T17 is equal to this. Alright, now let's solve the other question. It says that the common ratio of a GP is 2. So R, number 2 says R is 2. If the fifth term is greater than, now T5 is greater than the first term by 45. So what is the first term? Let's say A is going to be the first term. So A is A, of course. But the T5 is going to be AR raised to the power 4, isn't it? Now it now says that this T5 is greater than A by 45. So if it's greater than A by 45, it means that T5 is going to be what? A plus 45, isn't it? And T5 is already this. So it means that AR raised to the power 4 is equal to A plus 45. Alright, so we can now solve further. Now what do? We can take, since our R is known to be 2, we are given the R to be 2. So what do? We solve into this so that we have A into bracket 2 raised to the power 4 equal to A plus 45. So what do we have? A dot, that is times 2 raised to the power 4 is going to be 16 equal to A plus 45. So we have 16A now equal to A plus 45. Now what do? We collect items. Subtract A from both sides. This becomes 0 and A minus this is going to be 15A is equal to 45. Alright. So what do we have here then? A will be equal to, we divide both sides by 15. So that A will be equal to 45 over 15, which is what? 3. Alright, so A is equal to 3 here. Now we have to find the fifth term. So T5 rather, which is fifth term, recall is what? A raised to the power what? 4. Isn't it? So that we have T5 then will be equal to A, which is 3 now, into bracket 2 raised to the power 4, because R is 2. So we have equal to 3 by 2 raised to the power 4 is what? 16. 2 raised to the power 4, 16. So we have 3 by 16 is going to be 48. So we have 48 as our T5. And that is the final answer for the second question. Now let's move on quickly to the sum of a geometric progression. Now, how do I approach this? The sum of a geometric progression, that means the series of a geometric progression or geometric progression in series. So what do I have? So for example, the sum of a particular geometric progression is given by A, my first term, plus my second term, plus my third term, all to nth term, isn't it? So I could have A plus AR plus AR squared. This is my first term, second term, third term. Fourth term will be AR raised to the power 3. Fifth term will be AR raised to the power 4. So you can continue that way. Now I'm going to stop here, plus dot 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 AR, our nth term, raised to the power n minus 1. Is that clear? Alright. Now, what do I do? Because I want to take this sum, I can decide to multiply this, all of this, by, I want to generate a second equation by multiplying through by the common ratio. If I multiply through by the common ratio, I have RSN, R sum of n term, equal to, if I multiply this by common ratio, I have AR, plus, if I multiply this by common ratio, I have AR squared, plus, if I multiply this by the common ratio, I have AR cubed. If I multiply this by the common ratio, I have AR raised to the power 4. Plus dot dot dot. Now if I multiply this by the common ratio, what does that give me? AR raised to the power n. This thing means over R, isn't it? Raised to the power minus 1 means over R. So times R. What does that give me? AR raised to the power n. AR raised to the power n. Alright, now what do we do from here? We can decide to subtract this equation from this equation, or this equation from this equation. So, but let's just go like this minus this. Alright, so subtract, so this is equation 2, and equation 1. Okay, so subtract equation 2 from 1. Alright, so we have Sn minus Rsn is going to be equal to, if I subtract this from this, now this and this I can't subtract it because they are not like terms, alright? So I have A left here. Now, if I subtract this from this will give me 0. If I subtract this from this will give 0. I can subtract this from this will give 0. Now, the next term after this is what? A raised to the power R raised to the power A R raised to the power 4. So you see, it's like it's alike, alright? If I have A raised to the power 5 here, then see the next term that's A raised to the power 5, alright? Once I get to nth term, the last term here, and if I decide to subtract this from this, now note that I multiply this term by R to get me this. So it means that before I got this, there was a term. You know that we are progressing by multiplying by the common ratio. So I progress here all through by multiplying by the common ratio, and I progress here too by multiplying by the common ratio. It means that before I got this term, I had this term AR raised to the power n minus 1. Then it was this that I now multiplied by R. Do you get that? It was this that I multiplied by R, just like I did here, that now gave me this. Alright, so it means that this term will cancel out this term. There is an initial term before this that cancels out this. Just like we did this, there is a term after this. If we had continued the progression, there is a term after this that is equal to this. So it cancels each other out. So we are left with this guy, A, the first term, and the last possible term. So we have A minus, because we are subtracting AR raised to the power n. I hope that is clear. If it's not clear, please rewind the video so that you understand what I explained. There is an initial term before this, which became this by multiplication with R. And why do you multiply with R? Well, that's what we have been doing basically. A, to get the first term, you have the first term is A. To get the second term, you multiply A, the first term, by R. You get this. The same way, we decided now to multiply the sum by R, which is the common ratio. So R times this becomes AR. R times this becomes AR squared, times this AR cubed. You understand? So before we got this, we had this. So look at it. Look at it. It's just like we have repeated this. Now, just before we got it, we had this. Then this multiplied by R gave this. Alright. So I hope that is clear now. So what do we have here? We can decide to we have like terms here. So we have S sub n. S sub n becomes S sub n is common into bracket. If I remove S sub n, I'm going to be left with 1 minus. I take care of S sub n. I have R here is equal to A is common here. A into bracket. If I remove A from here, I'm going to be left with 1. A cos A, we have 1 minus. I cos A from here. I have R raised to the power n. Is that clear? Now, what do I have here? Since I have my S to infinity is equal to A over 1 minus R. The same rule applies. This is when R is less than 1. And if R were to be greater than 1, the sum to infinity would be A over R minus 1. And that is the sum of a GP. Alright, we can begin to apply this in solving questions. In our next video, we are going to be solving a lot of questions both on AP and GP. See you there. And until then, do well to subscribe to the channel and stay blessed.